In this video, we'll explain how ultrasonic thickness gauges work, detailing the parts and how the technology is used. You'll learn how these devices use ultrasonic sound waves to measure the thickness of different materials accurately and non-destructively. We'll also cover the key features and benefits of ultrasonic thickness gauges, giving you a comprehensive understanding of this essential tool. Let's start by identifying the key components of the device. The ultrasonic thickness gauge features several key components. First is the main body that houses all the essential electronics and components. The keypad is used to navigate through the settings and options. The TFT display shows all relevant information and readings. The battery cover is where the batteries are housed. The P or R socket is used for connecting the probe, while the probe zero disc is essential for calibrating the gauge. The Bluetooth status indicator shows the connection status. USB interface and probe that is connected to the P or R socket and contacts the material being measured. Lastly, the label provides important device information. To start the instrument, press the button until the display activates, then connect the probe to the device. Next, set the work mode and ensure the correct probe model is selected. Perform the probe zero operation only in pulse echo mode. Do not do this in echo mode. For accurate measurements, set the correct sound velocity and enter the nominal thickness. To measure thickness, apply a small amount of couplant to the material and press the transducer firmly against the surface. The display will show the thickness. If the reading is unstable, ensure the transducer is flat and properly coupled. The device updates measurements every second while the transducer is in contact and holds the last reading when removed. Be mindful that leftover couplant or thick coatings can affect accuracy, so it's important to use the instrument correctly. When measuring a pipe and tube for smaller pipe diameters, two measurements should be performed, one with the wear face gap perpendicular, another with the gap parallel to the long axis of the pipe. The smaller of the two displayed values should then be taken as the thickness at that point. When measuring on hot surfaces, it may also be necessary to use a specially constructed high-temperature transducer. The device also offers advanced features that allow you to measure through paint and coatings without needing to scrape them off, unlike other instruments that require paint removal for accurate thickness measurement. You can adjust settings such as view mode, nominal thickness, limits, display, sound, and system configurations, as well as save and manage records. For more information on the ultrasonic thickness gauge available in the Philippines, visit our website at sensors.ph.